so welcoming and warm. Yeah, it's really, really nice to get the presentation, to the possibility to talk about migraines today. So today we'll be covering the metabolic phase of migraine, and we'll be discussing whether migraines could be at least partially as much a metabolic disease as they are a neurological one. We'll be discussing the potential migraine protective mechanisms of ketosis. And don't worry if you don't suffer from migraine, you realize a lot of the mechanisms may be generalizing to other neuro or even psychiatric diseases. We'll be talking about our Migraine trial, which is a phase 2A trial on exogenous ketones in migraine prevention. And finally, we'll discuss potential therapeutics and therapeutic implications, because I guess the patient is always the most important thing to keep in mind. So I have one conflict of interest. I'm the CEO and founder of KetoSwiss, where we provide or develop potent ketogenic therapeutics for neuro and psychiatric diseases with a metabolic component. So you can see our launch brand BrainRitual and the first migraine medical food that we're launching called Migraine. And really we try to develop effective but side effect free solutions under the 𝗖𝙗𝐵 medicine umbrella for the therapy or the prevention of neuro and psychiatric diseases, starting with migraine, based on solid scientific evidence and also inspired by evolution. Now let's take a look at migraine. These are my attempts to illustrate what a migraine attack feels like about 8 years ago, when I still had chronic migraines with over 20 days in pain per month. Migraine headache is typically moderate to severe, unilateral, and comes with a lot of associated neurological symptoms, such as visual disturbances or motor disturbances, even sensitivity to light, noise, even smell, sickness, nausea, and sometimes even paralysis of parts of the body. Migraines typically come in 3 phases: a premonitory phase, a post-term phase, that are preceding or after the headache phase, and these other phases can be as debilitating as the actual headache itself. And in a third of sufferers, you also have something called the aura phase, which is that transient period of sensory disturbances that is either visual, but can also be like the visual field, or can be all the way up to these sensory motor disturbances, such as paralysis of part of the body that may even feel like a stroke. Interestingly, migraines are genetically more related to epilepsy than to common tension type headache. And I want to know, before we dive into this, who of you actually has migraines? Okay, that's a couple. No, that's actually quite a few now. That's about a third just raised their hands. And who knows somebody who has migraine? Okay, I would say that's 80 to 90%. So you are not alone. Migraine is actually the third most common of all diseases in the world. So every seventh of us is suffering from it. 1 billion people in the world, and still it's rarely discussed or talked about. And I want to leave you with one question. Does it strike you as likely that something as common as migraine that affects 1 billion people in the world is a small mutation or an accident of nature that does not have any evolutionary advantage? And we'll come back to that question. It's also extremely expensive, with $100 billion in costs, direct and indirect, in the world, just in Europe, but even more worldwide. So it's something that everybody should be talking about or caring about, because it's just so expensive. And there's 0 preventatives that address the root cause of migraine. Everything we have is just pain treatment, symptomatic treatment only. So we want to change that. But how does a migraine happen? What is a migraine? Why is it happening? And we know that the headache phase, so what hurts, it's actually due to the activation of nociceptors, so channels that hurt, in the so-called trigeminal vascular system, which is basically the nerves that innervate that facial region here and parts of the skull. But that doesn't really tell us anything, because how and why does the trigeminal vascular system get activated in the first place? So we only have moved the problem one step ahead, but we don't actually know the answer of the problem. But when we try to look at that question, let's look at some of the trigger factors that we know are triggering migraines very frequently. We have a list of things. For example, strenuous exercise, too little or too much sleep. Then there's intense sensory stimulation, such as blue lights or Swarovski lights. We have stress, hypoglycemia, so fasting is a very potent migraine trigger actually. We have weather changes, especially low pressure. We also know that hypoxia, so lack of oxygen can trigger migraines, as well as alcohol. I was looking at this list of seemingly completely unrelated trigger factors. I was wondering, what do they all have in common? Why do they all trigger migraines? And there's actually one common denominator between all of them, and that is they negatively impact energy levels in the brain. For example, via increasing free radicals, this oxidative stress, and small bombs that can damage mitochondria and impair energy metabolism. On the other hand, if we look at some of the substances that we know, or things that we know are migraine protective, such as aerobic and exercise, or micronutrients, CoQ10, antioxidants, riboflavin, which is vitamin B2, or even binge eating prior to the attack, which a lot of people are experiencing, including me, like this hunger for fatty, high glucose foods just before the migraine pain hits, we can argue that they are actually energy conserving. So a few years ago, I was wondering, could migraine be in fact an energy deficit of the brain? And if that is the case, what can we do about it? Now let's look at some of the evidence that migraine actually has a metabolic phase. First thing to look at is glucose metabolism. Now this is relevant for every single one of you. Actually, your brain is a fascinating organ. It's one of the most fascinating, which is why I went into neuroscience in the first place. It only makes up 2% of your body's weight, but it's consuming over 20% of your total energy needs. So it's very energy hungry, but it cannot actually store energy very well. And it's protected by this thing called blood-brain barrier, which means that only a very few selected fuel sources from the circulation, from the rest of the body, can actually get into the brain. So the brain is very energy hungry, but it's also very much dependent on outside energy supply. And that makes it very vulnerable to any shortcomings. And in the modern Western world, the way we eat today, the brain is primarily dependent on glucose on its energy supply. It's a not redundant system. It's very, very vulnerable because there's only one thing that can supply it. And even any one of you cannot store more than 24 hours of glucose supply in your body. So this is not optimal. We know that migraine has been associated with glucose for over a century. It has been referred to as a hypoglycemic headache over 100 years ago, and that got forgotten about. But we also know that hypoglycemia fasting is something that is not only a very prominent migraine trigger factor, but it also can be used experimentally to trigger migraines in the lab. Over 50% of patients who just fast them and then they get a migraine. Now, other evidence is interestingly during Ramadan, when you fast most times of the day, migraine frequency increases versus if you look at type 2 diabetes that is uncontrolled, high blood sugar levels. That's actually migraine protective. So migraine frequency goes down in uncontrolled diabetes without hypoglycemic attacks. Right, so then if we look at some of the premonitory symptoms, all the symptoms that are happening when you have triggered a migraine but the headache phase has not yet started, and you compare it with symptoms that we know are part of hypoglycemia, you find a lot of common grounds. For example, dizziness, pale skin, cold hands, and feet, binging on foods that are sugar cravings, yawning, nausea, low blood pressure, shaking, cognitive difficulties, tiredness, fatigue, visual dysfunction even, or slurred speech. All of these happen in both states. Now there's something called the oral glucose tolerance test, and we've already mentioned it before, so I won't go into details, but this is actually a mechanism to very reliably also trigger migraines in the lab. You just give that on an empty stomach, and then in about 50 patients, you'll trigger a migraine. Now the interesting part is, in the patients that do get a migraine, we see a very abnormal or different metabolic response, which is elevation of fatty acids, so lipolysis, a new alternative energy source is generated in those patients. We see an increase in ketone bodies, ketoneogenesis is turned on, glycerol, cortisol, all of this rises already before the headache phase is starting. And irrespective of food intake, so even if you eat carbs, that's important as well. All right, there's more evidence, and that comes from neuroimaging studies. Here, PET imaging. If you do PET imaging in migraines, even between attacks, you find brain hypermetabolism, which means some brain regions have less glucose or less metabolism happening than they should. There's another fascinating technique called phosphorus MREX, phosphorus magnetic resonance spectroscopy, very difficult word, very simple findings. You find an impairment in oxidative phosphorylation, which is part of the energy metabolism, energy generation in the mitochondria. That's impaired, and you find between migraine attacks interictally 16% decrease in ATP levels. ATP is the energy currency. So these migraine brains are in fact starving. Now, mitochondrial dysfunction is something we've been discussed. That plays a big role in migraine as well. We can see, for example, in mitochondrial dysfunctions, mitochondrial disorders, migraine prevalence is increased by twofold, so 30 instead of 15%. We see that mitochondrial enzymes are decreased in activity, so that's also bad for migraine energy. We also see something in so-called genome-wide association studies, which is when you take hundreds of thousands of patients, you look at their genome, and then you see what kind of a difference do they have in some gene locations to normal, healthy controls. You'll find an enrichment in genes in migraine that are part of mitochondrial functioning in common migraine. Again, supporting the fact that mitochondrial functioning does play a role in migraine pathophysiology. Clinical observations, to me, always the most important piece of evidence. We know from RCTs, from randomized controlled trials, that antioxidants such as CoQ10 are migraine protective in high doses, as well as riboflavin, which is part of energy metabolism as well. You dose at really high, 400 milligrams, that can help some patients as well. And even pharmacological agents that we're using in migraine today, such as this anti-convulsant drug, 𝗖𝐵 that you may know from epilepsy, that has been shown to have metabolic actions as well. It's actually prolonging mitochondrial survival, and it's reducing inflammation and increasing mitochondrial function and reducing oxidative stress, amongst others. So even in drugs, we see that mitochondrial link or metabolic link. Last but not least, ketogenic diets, which is probably why most of you guys are here today. There's 3 randomized controlled trials using ketogenic diets in migraine, and severity of migraine, migraine frequency, and even medication use are reduced by 50 to 80%, depending on study. All right, we talked about oxidative stress, which are these free radicals. Free radicals are basic molecules that are highly reactive, chemically active molecules, a bit like bombs, that wherever they hit, DNA, lipids, proteins, they cause destruction. So in excess, they're very bad. You need oxidative stress for cell signaling. There's always a balance between things usually, but too much oxidative stress is bad for you if it exceeds your antioxidant capacity or your capacity to catch these bombs and neutralize them. Oxidative stress is, as we discussed, the common denominator of all these seemingly unrelated migraine trigger factors. It's also associated with migraine, meaning that you have, for example, free iron elevated in the migraine's brain. Free iron is highly pro-oxidant. You have heavy metals associated with migraine, and you have reduced antioxidant capacity in migraine as well. And that is something that we looked at in a study in Basel, in Switzerland, where we looked at different methods or measures of mitochondrial functioning and antioxidant or oxidative stress. And we've looked at, for example, total antioxidant capacity, the capacity of a person to catch these free radicals, oxidized LDL, again that's damaged by oxidative stress, alpha-lipoic acid, a very potent endogenous antioxidant. We looked at lipid peroxide, thiols. Thiol groups are the groups of proteins that can actually catch or neutralize the bombs. And then HbA1c, which is long-term blood sugar, and lactate as well. What we found, and I'll show you the other slides, which is a bit more easy to see, is that all of these in a larger proportion of our patients were abnormal. For example, thiol groups were reduced, peroxides were in 50% of patients were increased, which is a measure of oxidative stress. Total antioxidant capacity was down, so these patients actually cannot neutralize oxidative stress so well, which means, again, energy metabolism in turn will be malfunctioning. And the most important finding was alpha-lipoic acid was reduced in 90% of patients, which again indicates that oxidative stress could be playing a huge role in migraine. And the last interesting finding is HbA1c was too low, not too high, so we kind of have the opposite spectrum of a classical metabolic disease such as diabetes. They're hypoglycemic more than hyperglycemic. And lactate levels were much reduced, and that was something I was wondering about. Why is lactate not high? Because that's the typical thing you find in metabolic dysfunction. But then I thought, well, lactate, like ketone buddies, can replace up to 60% of the brain's energy needs. So these patients may be using lactate because they cannot use glucose as well to meet their brain's energy demands. But that's just a hypothesis. Now, if migraine is in fact this brain energy deficit, then what can we do to mitigate the problem? And you may have guessed this finally when ketone buddies enter the picture. Ketone buddies are this group of 3 molecules. Chemically, only one of them is a ketone. The others are just called like that because some medical doctors thought it's a good idea to call them ketone buddies. The first one is acetone. It makes up about 2% of the total ketone buddy concentration. And that is what you can measure and what you breathe out in breath. That's the first ketone buddy. So if you use a breath meter to measure whether you are in ketosis or not, you are measuring acetone. The second is acetoacetate. That's actually a ketone chemically, and that makes up about 20 to up to 40% of your total ketone body levels. And this is what you measure in urine. If you use urine sticks, you'll measure acetoacetate. And the most prominent one is called 𝘖𝐵𝑡𝐻-hydroxybutyrate. The human identical one is called 𝑑-𝘖𝐵𝑡𝐻-hydroxybutyrate, and that is what you measure when you prick your fingers. We've had a look at the keto motor device. You'll be looking at as beta-hydroxybutyrate, and that's the most prominent one, between 60 and 80% of total keto body levels. Okay, so we published a paper on the potential mechanisms of ketone buddies in migraine prevention. Why could ketosis be such a good idea? And the beauty of this beta-hydroxybutyrate molecule is that it's both a metabolite as well as a signaling molecule. And the signaling molecule acts a bit like a hormone, so it can even change gene expression, what 𝐲𝐴 was talking about. And if you don't have migraine, still listen to this, because this could have implications way outside of migraine as well. We know hyperglycemia plays a role in migraine, but also potentially in other neuropsychiatric diseases. It has been associated with migraine for over a century. And we know that ketone buddies can actually offer the brain an alternative, but not only alternative, also a more efficient energy source. So per oxygen molecule consumed, you get more ATP. So you get more bang for your buck, which is great. Now, glucose transport can be impaired not only in migraine, also in epilepsy or other diseases. This is basically then affecting either glucose transport, which is the glutes. Glucose transport is kind of like the taxi or the tunnel that brings the glucose taxi into the cells. There's different ones. Some of them are insulin dependent. Insulin is the taxi driver that shuttles glucose through the tunnel in the taxi. And some patients need both the tunnel and the taxi. Now, if you're insulin insensitive or insulin resistant, you will not get glucose into the cells as well. Or if you don't have the right tunnel, you won't get either through either. So the two problems. Now, sorry, I missed the point. Ketone buddies are actually using a different tunnel, and they don't need a taxi driver. So if you have problems with any of these, ketone buddies are using so-called MCT transporters, monocarboxylate transport system, so you can circumnavigate any of those issues. What about mitochondrial functioning? This plays a role in migraine, and so many, I cannot name a single neuropsychiatric disease where mitochondrial functioning is not an issue, so this is important for many things. We know that ketone buddies, beta-hydroxybutyrate, can help increase mitochondrial biogenesis, so more of these mitochondria are being built. And important for mitochondrial health is, of course, also this thing, oxidative stress comes up again. And here we have two advantages. When we are burning beta-hydroxybutyrate in the mitochondria, or ketone buddies in the mitochondria, we're producing less free radicals in the process. So this is already great, but it gets even better. Ketone buddies themselves are potent antioxidants, meaning they can catch the free radicals that are produced while they are being burned. So it's a double protection in that sense. All right, similar to epilepsy, cerebral excitability plays a big role in migraine. We have a hyperexcitable brain, and that can lead to more migraine attacks and all these hypersensitivities that we see in migraine. What do ketone buddies do? Again, they have several mechanisms how hyperexcitability in the brain could be positively impacted. One of them is you can shift the equilibrium between the excitatory neurotransmitter glutamate and the inhibitory neurotransmitter GABA towards GABA, meaning that more GABA is being produced, which is calming you down and could also be playing a role in, for example, depression or epilepsy. The other way that ketone buddies seem to influence that process is via inhibition of glutamate transport. Glutamate needs to get where it needs to go. If you inhibit the transport system, you also get a more relaxed or a inhibitory state of mind. There's one more phenomenon in migraine, and that is very familiar to you. If you have an aura is this sensory phase of disability, could also be a motor disability, like the paralysis of half of the body. And the physiological correlate of this phenomena is called the cortical spreading depression. It's actually quite an interesting, maybe even scary phenomenon, where an electrical wave spreads across your visual cortex in the back, a bit like a tsunami, and where it's passed, it leaves destruction and a period of depression or no activity. And this is why you're either paralyzed or you can't see. And you can literally watch that wave travel when you have an aura. You can see it across your visual cortex, so it's quite fascinating. And this phenomenon is very much dependent on energy reserves or energy state in your brain. So if you're hypoglycemic or hypoxic, this wave will spread more easily and will be easier to induce. And you might have guessed it already, if you're in ketosis, the threshold for CST goes up tremendously, so an aura phase cannot be triggered as easily as well. Inflammation, big topic, involved in almost any disease that you can think of, including migraine, and I'll show you a bit of evidence about that in a little while. 𝗖𝙗𝙤𝙪𝙩 is also anti-inflammatory via inhibition of the NLRP3 inflammasome. So this is great news, not only for migraine, but also for any condition that has inflammation as part of the problem. Last but not least, the gut microbiome. We've heard about this thing. We're more bacteria than we are actually human if you just count the cells in total. And our gut microbiome is so important for anything we do. It's a little factory, basically, sitting in our gut that is protecting us from the outside environment, from toxins, from other things, but it's also making both micro and macronutrients for our brain health. So it's making butyrate, which can fuel our brain cells. It's making vitamins. Sorry, I always say that word wrong, so I'll say it right the first time. Vitamins and other stuff that we cannot make ourselves that are essential to take up in our diets. So that's something that gut microbiome can do, and there's evidence to show that gut microbiome is disturbed in migraine and in other diseases. And actually, the ketogenic diet in epileptic children, it's been shown that a lot of the treatment effect is actually driven by changes in the gut microbiome. So something not to be overlooked. 𝗖𝙗𝙤𝙪𝙩 is very close to butyrate. It can feed our gut cells, our gut microbiota, and can feed the brain as well. Alright, so this is just a summary. I want to leave you with that one thing, that migraine, as any other really complex civilization disease, is a multifactorial problem. There's so many different genes that together impact the phenotype of your personal migraine or somebody else's. Pharma tries to address that problem by designing a small molecule that will bind to a single target, and then they think they can fix something that is so multifactorial and multigenic, such as migraine. That approach will never work. It won't work with migraine, it will not work with Alzheimer's, it will not work with depression or any other civilization disease that is common, meaning more common than 1%. The beauty of ketosis or 𝗖𝙗𝙤𝙪𝙩 is that it can impact any of these mechanisms positively that we have just discussed. And it's a multifactorial solution to a multifactorial problem. And then I want to answer the question I started with as well. Does it strike you as likely that migraine, being so common, did never have an evolutionary advantage? The answer is most likely not. It seems more likely that the genetics that make up the migraine phenotype had an evolutionary advantage. It seems to be a warning signal that is protecting you or the organism from the deleterious effects of too much oxidative stress or too little energy in the brain. It's forcing you to rest until energy homeostasis in the brain is restored. So migraine is a good thing, which means that if it's not your genetics, it has to be your environment. And the good news is we can fix the environment, and Lucia has just explained to you how. And that is what I'm proposing as well. And this is where ketosis comes into the picture as one of the potential treatment avenues that you can go down if you have a neuropsychiatric problem such as migraine. How do we get there? Well, these are the final few slides, so bear with me. Thanks for the patience. Fasting basically is endogenous ketosis with severe calorie restriction. You've probably all done it once in a while or not. The second option is that of the ketogenic diet, which we've talked about or which you've heard before, which is basically mimicking starvation or fasting, but it does not come with calorie restriction necessarily, but your liver starts to make those ketone bodies. Once you greatly increase your fat intake to 70 to 80%, You have moderate protein intake and very limited carbohydrates. The third option has already been introduced this morning by our colleagues from 𝙁𝙤𝙤𝙪, and that is that of ketogenic supplements, which is basically exogenous ketosis, meaning it's not your body that makes the ketone bodies, but you ingest them and they come from outside. And there's various different solutions. We've heard about ketone esters. We have used ketone body salt in our clinical trial, which is basically the human identical 𝘖𝙗𝙬𝙪 molecule bound to a mineral, for example, sodium, potassium, magnesium, or calcium. And that led to our clinical trial, which is a phase 2A randomized, placebo-controlled, double-blind, crossover efficacy and safety trial on exogenous ketone body salts in migraine prevention. We used 18 grams of calcium and magnesium BHB in powder form versus placebo in 40 medium to high frequency patients. Now, the study design was crossover, which is an advantage because everybody is their own control. So everybody has their own personal placebo effect, and that just greatly increases the power somewhat. We had two baseline comparisons, and also a washout period. The study resulted in, unfortunately, the almost 20% reduction in migraine frequency that we saw in the small trial were overall not significant, but it's the effect size that you see in most migraine trials that are of larger population. But we had a 30% responder rate, and in those responders, we had an over 60% reduction in migraine days over placebo, which is better than anything we have right now. And we could use biomarkers. We found biomarkers that accurately predict who is a responder and who isn't, which we call the metabolic migraines, where metabolism is really key or the most important part for their personal migraine. And there was no safety concerns. My couple of last slides is actually my most favorite, but they look a bit complicated. Just focus on the first and the last bar. This shows you the difference between responders and non-responders at baseline. At baseline, responders were producing almost 40% less 𝘖𝙗𝙬𝙪 than non-responders. So their endogenous ketone body production was quite decreased, which is bad for the brain and other organs. On the bottom side, you see high-sensitive CRP, which is a general marker for inflammation. These patients were 160% more inflamed than the ones that did not have metabolism as a primary cause or involvement. Now, here you see that after only 3 months of migraine intake, which is this 𝘖𝙗𝙬𝙪 mineral mix, their own ketone body production after the trial went up by 60%. So suddenly their bodies, their livers were able to make that energy source that the brain needs so badly again. And the other great finding on the bottom, you see that, or on the top now, is that CRP inflammation was decreased by almost 60%. And then other things that happened is triglycerides went down, glucose went down, so a lot of other good factors happened as well. Okay, I would like to conclude with some potential therapeutic implications. I'm not a medical doctor, don't take this as medical advice. This is just, if I was a chronic migraine patient again, this is what I would suggest, or this is what I would be doing. First step is individualized supplementation of micronutrients and hormones, because without these micronutrients, vitamins, trace minerals, antioxidants, your mitochondria, your powerhouse in the cells, cannot make adequate energy. The same goes for hormones. As Dr. Jamie has explained, if you don't have the right amounts of hormones, you will not make good energy either. And then the second step is reducing oxidative stress and increasing antioxidants. This affects all areas of your life. Physiological speaking, psychological, physical, or chemical stress is very similar. So it's so important that you reduce toxins, you eat a whole foods diet, you reduce physical stress, don't over-exercise, but you also reduce all the psychological stress. Learn to say no, get rid of toxic relationships that are not doing you any good. Just because you were friends 20 years ago doesn't mean that person is any good for you today. So that's important things across the spectrum. Stabilizing blood glucose is important, and that is at least a low GI diet. And also, again, stress management. Whenever you're super stressed, your cortisol goes high, your glucose goes high, and you have this roller coaster. I've been wearing this permanent glucometers, and it's really like, even at the night, if you're stressed, your blood, it looks like you've had a brownie, and it's just your stress levels that are shooting up your glucose even at night. It's quite fascinating. Last but not least, if none of this works for you, then you really have to give the brain an alternative energy source, and that is ketone bodies, either exogenous or endogenous or both, if you can manage. Last slide is, now we discussed all this migraine stuff. You may not even have migraine, but there's more and more evidence. The more I was diving into this topic, the more it became clear that what I was researching on migraine actually can be generalized to so many other conditions that have a metabolic component to it, a mitochondrial dysfunction component. And I just want to finish by saying that, for example, there's fairly good evidence in Alzheimer's disease that Alzheimer's could be a type 3 diabetes, where what you can see here is if you give glucose on the left to an Alzheimer brain, it doesn't do much. It stays very calm. There's not much activity going on. If there's not much activity, you're not really doing anything or thinking anything. On the right side, you see when you give a precursor to ketone bodies, these ketone bodies can still be taken up by the brain here in the neuroimaging study and can be used and metabolized. And that's very powerful. On the bottom, you see a graph where it basically suggests that the higher the ketone bodies in the blood, the better your cognitive performance in this mild cognitive impaired pre-Alzheimer patients. And with that, thank you so much for your patience.